Hello students, welcome to Suri Joyendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 2 of a unit Gravitation. So let's begin with today's class. In today's session we are going to discuss about the gravitational force. So let's begin with the gravitational force. The first question is, what is gravitational force? We can say it is a force of attraction. Please have a focus on this. It's a force of attraction. It is always an attracting force between any two bodies due to their mass. So this force does exist because of their masses. Yes. So any object that has been dropped from somewhere will came to earth, as you can see in the diagram. One more case is that, let's say this is earth. Let me show you. Yes, this is earth, and this is, let's say, moon. Then moon is revolving around the earth. Why? Because of their gravitational force of attraction between these two. So this is a force of gravitation. It is always attractive in nature. And let's look at the some other properties of gravitational force. We can say that gravitational force between two bodies form an action and reaction pair, i.e. the forces are equal in magnitude but opposite in direction. It is something like that let's say this is first body, this is second body. Then the this is first, this is second. Then first is the force applied on the second by the first. The second is the force applied by the second on the first. So this F12 and F21 both will be the equal. They are opposite in direction, same in magnitude. So they are always equal and opposite. And this can form an action reaction pair. This can form an action reaction pair. I hope this is clear. So F12 is equals to F21. They always form action reaction pair. Next, gravitational force between two bodies is independent of the nature of the medium. Always remember this. Let's suppose the situation is, this is first, this is second. They This two masses m1 and m2, and at this point of time we don't know that what exact amount of force does they have exert. But let's understood that this is the separation r, and for air, when they have been placed in air, the force between them is F. Now, a same particles separated by same distance m1 m2, and the separation between them is r. If they have been put in a water, then F in water will be same as that was F in air. So this gravitational force between two body is always independent of the nature of the medium. And one more, gravitational force is negligible in case of the lighter bodies. That means the gravitational force applied by the lighter bodies would be a negligible. I hope this is clear. Next, gravitational force is appreciable in the case of a massive bodies like stars and planets, as this is earth, this is ourself. Then then the gravitational force applied by the earth, it will attract us and we are going to moving down. But we can say that even we as a human apply a gravitational force on the earth. Then we are the just we can be considered ourselves as a massless body when we compare ourselves with the earth. So Earth's gravitational force is negligible, while the gravitational force applied by massive body, it can create a massive effect. I hope this is clear. One more thing, it is the weakest force among all the forces but has the longest range. In the last class we were discussing that fundamental forces in nature. So we have four fundamental forces. Which are they? Which are they? Which are they? Yes. First is the gravitational. Second, electromagnetic. Next, it's a strong nuclear force. and next it's a weak nuclear force. So these are the forces, these are the, we can say, fundamental forces in nature, and within this all fundamental forces, gravitation is the weakest one but having the longest range. Ideally it is having an range, ideally it is having a range of infinite. Yes, please do remember this. It is a conservative forces, it is a conservative force in nature. Now again the question arises, what conservative means? What does it, what do you understand by conservative force? We have discussed about this conservative nature in the unit number 5, work, power and energy. So this depends on the initial position, this depends on the initial position, this depends on the final position, but this does not depend, this does not depend on path it has taken. I hope this is clear. So it is conservative force in nature. While I say it's a conservative force in nature, I mean it depends on the initial position, it depends on the final position, but it does not depend on the path it will take. So it is conservative forces in nature. One more, it is communicated through gravitones. This is what we call as the mediating particles. It's a mediating particles. Yes, but again, this mediating particle named a graviton, it's an hypothetical concept. Yes, next it is mass dependent and charge independent. It does not depend on the charge, that we understand. I hope this is clear. So do you understand all the properties, all the properties of gravitational force? Are you sure? Let's have quick questions. Gravitational force is, check the options. It says the gravitational force is force of attraction between the earth and any other body, force of repulsion between earth and any other body, strongest force, false, short range, no, it's a range, infinite, it is a repulsive force. So this is incorrect, this is correct, it's a force of attraction between the earth and any other body. Next, which of the following is the property of gravitational force? It is weakest of all the forces, yes. It has longest range, yes. It is mass dependent, yes. So all of the above, yes. This would be the correct answer because all the properties are correct. I hope this is clear. Is it? Is it clear? Now let's begin. Let's begin with the universal law of gravitation. We are about to derive mathematical modeling of gravitational force. So focus this very carefully. So let's look at the basic idea for universal law of gravitation. According to the Newton, he says that moon is revolving around the earth in a circular orbit of radius that we call as an rm, and moon is subjected to a centripetal acceleration due to earth's gravity. So if I write this, it's an acceleration. I understood that AC is equals to v square by r. This is the centripetal acceleration. So centripetal acceleration on the moon will be equals to its a v square divided by rm. And while I write v, as I have mentioned that it has been moving in the circular orbit, I can write like this. It's a t is equals to 2 pi r by v. So if I replace this v, if I replace this v with the help of 2 pi r by t, then this v could be written like this and divide by rm. If I solve this, I am having an am. Its a acceleration of moon will be equals to 4 pi square by t square into rm. While I am writing this, where if so v was the orbital speed of the moon and t is the time period of the moon which was 27.3 days, and rm It's a radius of the moon orbit. It's a 3.84 into 10 to the power 8 meter. So if I am having the relation that it's an am was equals to 4 pi square multiplied by rm divided by t square. If I'm going to replace this value, replace the value of rm, replace the value of t square as well as 4 pi square, I'm having am which is equals to 1.63 meter per second square. So if I understand that am, it is very much less than the acceleration due to gravity on the surface of the earth, which we call as a g. This clarity shows that the force of earth's gravity decreases with the distance from the earth. So as long as we are going, we are having a less gravity, that we understand from this aspect. One more thing, Newton assumed that this force changes inversely as square of the distance and calculated the ratio of the acceleration due to gravity of the earth and the moon. How? Let's have a look. It's an am is inversely proportional to the rm square, and g, it's an gravitational acceleration of earth, would be re square. It's a 1 by re square. So if we take a ratio, then the ratio will give him, it's a 3600. This value is an excellent agreement with the values of the g, which is equals to 9.8 meter per second square, and am was 1.63 meter per second square. I hope this is clear. Is it clear? So this leads us to the universal law of gravitation. I hope this is clear. Does it clear? Does it? Any doubts? No? So let's begin with the universal law of gravitation. But Newton got an idea from that it might be inversely proportional to the square of the distance between these two. So then he have given us the universal law of gravitation. What it is? Let's have a look. It says that every particle of matter attracts every other particle of matter with a force which is directly proportional to the product, which is directly proportional to the product of their masses, and inversely proportional to the square of the distance between them. So this is directly proportional, that we can call it's an f directly proportional to the m1 m2, and this is inversely proportional, that is f directly inversely proportional to the 1 by r square. If I want to write this two relations in a one frame, it's an f is equals to g m1 m2 divided by r square, where g is the constant of proportionality. We call it as the universal gravitational constant. While I call it universal gravitational constant, I mean that value of g is same throughout the universe. I hope this is clear. Yes, please always call it as a universal gravitational constant. This will make you understand that the value of capital G is never ever going to change, not dependent on time, not even dependent on location. I hope this is clear. Yes, let's move to the next. It says that quick questions. Let's have a look. Gravitational force is directly proportional to the, yes, the product of the masses. It is F directly proportional to the m1 m2. It was F direct to the pi r square. So this depends on the directly proportional to the product of their masses and inversely proportional to the square of the distance between these two bodies. So it depends, or it directly depends on the product of the masses. Next, gravitational forces is mathematically given as it's an F is equals to G into m1 into m2 divided by r square. No, I was wrong. This was the correct option. It was F is equals to G m1 m2 by r square. I hope this is clear. Is it clear? Is it any doubts? Is there anything? No? Great. Let's look at the next question. In the Newton's law of gravitation, G is called as the as universal gravitational constant. Yes. Acceleration due to gravity? No, it's a small g. Variable? No, it's a constant. Any constant? No, it is not any constant. It's a universal gravitational constant. So does it clear up till now? Are you sure? Are you sure? Can it be done? Can we do this? Are you sure? Can it be done? Can it be great? Now let's discuss certain aspects of universal gravitational constant. So when I say universal gravitational constant, when I say it universal gravitational constant, I mean it's an F is equals to G into m1 m2 divided by r square. If I make a relation according to the G, this is G is equals to F into r square divided by m1 into m2. Now let's first understood what would be the SI unit. What would be the SI unit of G? This force can represented by Newton. This square of the distance can be represented as meter square. This m1 and m2, this m1 and m2, this is kg, this is kg, so this will be the kg square. So SI unit of G is Newton into meter square divided by kg square. A CGS unit of G, this is Newton, and this is dyne. This is meter square. This is centimeter square. This is kg square. This is gram square. It's a dyne into centimeter square divided by gram square. Now let's derive the dimensional formula of the G. So for the force, it's a Newton, that could be kg meter per second square. So this is m1 l1 t minus 2. It is a kg into meter per second square. For r square, meter square, it's a meter square, it's an L2. I have written it over here. M1 M2, it's a kg square. I have written it over here. It's an M2 L0 T0. So if I solve this, it is M minus 1 L3 T minus 2. It's an M minus 1 into L3 into T minus 2. So we can say that universal gravitational constant is numerically equal to the force of attraction between two unit masses placed at unit distance apart. It is something like this, that G is equals to F into r square divided by m1 m2. So if force is of 1 Newton, distance is of 1 meter, and the product of this two is the 1 kg, then this is equivalent to the universal gravitational constant. I hope this is clear. Value of G, it's a 6.67 into 10 to the power minus of 11. 6.67 into 10 to the power minus of 11 Newton into meter square divided by kg square. And in the CGS system, the value of the G could be written as 6.67 into 10 to the power minus of 8. It's a dyne into centimeter square per gram square. I hope this is clear. Is it clear? Is it any doubts? Is there anything? Are you sure? Are you? Are you sure? Let's have a quick question. The question says universal gravitational constant is numerically equal to, yes, it's a force of attraction between unit masses placed at a unit distance. Yes, it is something like this. Look at this. It's a F is equals to G m1 m2 divided by r square. From this I can write this, it's a F into r square divided by m1 m2. So it's a force of attraction between unit masses. This 2 is the one placed at unit distance. So G is equals to F. Let's look at the other option also. The force of attraction between any masses. No, you cannot write this. That's why it is incorrect. Force of attraction between any masses placed at the distance. Again, this is incorrect. Force of attraction between any masses at any distance. No, absolutely incorrect. So I hope this is clear. Does it clear? Does it? Are you sure? Great. Now, let's look at this. Dimensional formula of gravitational constant. We already have derived this. We already have derived this. It's a g is equals to fr square upon m1 m2, and even you could have this. It's an m minus 1 into L3 into t minus 2. This would be the correct option. Next, the value of gravitational constant. The value of gravitational constant in SI unit. It's a 6.67 into 10 to the power minus of 11 Newton meter square per kg square. This is plus, so incorrect. Thus, in these two cases, powers are different one. It's a 10 to the power minus 21 and 10 to the power minus of 30. If they have asked for the CGS system, if they have asked for the CGS system, you can go with this. It's a 6.67 into 10 to the power minus of 8 9 into centimeter square per gram square. I hope this is clear. Now let's understand and go through the vector form of Newton's law of gravitation. Let's understand how the vector form will represent. It says that this is m1, this is m2, and these two objects, this distance between center of the first object to the center of the second, can be given as an r. Then it's a force on the second object due to 1, that would be equals to g m1 m2 divided by r square into r21. Here I have used r21 as the unit vector, and I can understand that force on 2 that is applied by 1 is in this is in this direction. It is in the direction of negative x. It's a f21. Now let's write down the F12. It's a force applied on the first particle due to second particle, that we can call as mathematically and numerically it's a gm1 m2 by r square by a unit vector r12. It is in the positive x direction. As you understand that in the first property, that this will create a force of gravitation, will create an action and reaction pair. Have you remembered this? Yes, this is what action and reaction pair is all about. But we understand that r12 is equals to minus of r21, and that's why f12 is equals to minus of f21. So gravitational force on a point mass, gravitational force on a point mass due to the number of other point masses. Let's say suppose the situation is one of the masses here, some other masses are there, m2 is there, m3 is there, m4 is there, m5 is there, m6 is there. So many masses are there, and you need to apply a force, you need to apply, and you need to check the force on the m1 due to other masses. So m1 is the given point masses, and m2 to m6 all are the other point masses that are around m1, and we have a respective distance. We can say the position vectors. It's an r12, r13, r14, and so on. r16 are the unit position vectors of the masses m2, m3, m4, m5, and m6 respectively from m1. So gravitational force on m1, gravitational force on m1 due to m2 is gravitational force on m1 due to m2 is, it's an f12 is equals to gm1 m2 upon r12 square into r12. Now now this is the just the gravitational force on m1 due to m2. Same way this is the force on 1 due to 3. Same way this is force on 1 due to 4, and onwards. So this will be something like this. This is force on 1 due to 3, force on 1 due to 4, force on 1 due to 5, force on 1 due to 6, and all this stuff. So so the resultant gravitational force on m1 is the vector addition. I say vector addition of all of this. So it is starting from the f12 to the ending up at the m16. If I write this, it will look like this. And when it is like this, we understand that this force F is equals to sigma I is equals to 1 to n. It's an MIRJ divide by it's square of the distance between these two particles. It's an Rij. It is just this scalar form. It is just the scalar form of the force between two masses. I hope this is clear. Is it clear? Even J could starting from 1 to n. I hope this is clear. Is it? Are you sure? Are you sure? Great. Now, let's look at one of the question, that how we could proceed and what would be the situation when we used to have the to calculate the force of gravitation. So let's understand that they say that three equal mass of mkg each are fixed at the vertices of an equilateral triangle ABC. We have three masses. It's an M, it's an M, it's an M, and they are placed on the vertices of an equilateral triangle. It says what is the force acting on a mass 2m that is placed at the centroid O of the triangle. Mass 2m has been placed at the centroid of the triangle, and what do you need to do? You need to find out the force acting on mass 2m. So always understand that this is a two-way approach. This is the two-way approach. First thing is always calculate magnitude first. So your first task should be always to calculate the magnitude. Now your second task would be find out directions of force acting. Next is the direction of force is to be calculated, and last let's apply law of vector addition to get an answer. I hope you understand this three-step process. First, when this kind of situation will arise to us, we will always calculate the magnitude first. When I say magnitude, I will not bother anywhere about the direction, and I will just focus that what would be the value of the force. So let's have a look how to deal with this. This was the situation. This is at these three corners. It's an M, and M. Here mass 2m has been placed. So let's give them a number. It's a first, second, third, and fourth. So let's first calculate the force due to each one. Then my question is, who will apply a force? Who will apply a force on 2m? It's a simple answer that everyone that you can look is all will apply a force of gravitation. So let's write it's a force on fourth due to first. It's a force on fourth particle due to first particle. So let's call this as a y. Y is the distance, y. It's a g into 2m into m divided by y square. So I have done at this part. Now let's call the force on the fourth particle due to second. It's a g into 2m into m divided by y square. So I have done this also. Let's call this as 3. It's a f force on the fourth particle due to third particle. It's again g into 2m into m divided by y square. So you have find out the force F4 1, that is the force applied on the fourth particle due to first particle. F4 2, that is the force applied on the fourth due to second. F4 3, this is the fourth, it is the force acting on fourth particle due to the third particle. Now let's work for the direction. As we understand that it is always attractive in nature, So this force 1 will be acting in this direction. I hope this is clear. This force 2 will apply in this direction, and this force 3 will apply in this direction. So the situation is something like this, that here a mass 2m is placed, and in this mass we have three forces. It is F41, this is F42, this is F43. I hope this is clear. Is it? Yes. So this is at 60 degree. Yes? No. This is at 120 degree. I hope this is clear. Yes, this is again at 120 degree. This will again at 120 degree. So if you understand the law of, if you understand the law of vector addition carefully, all this are same in mass. All this are same in mass. So let's just calculate the equivalent of this to F42 and F43. So let's calculate F resultant of F42 and F43. That will give me a 2 into F into cos of theta by 2. So that is equals to 2 into G into 2m into m divided by y square into cos theta by 2, cos 120 by 2, it's a cos 60. Cos 60 is half, so this is cot. It's a G into 2m square divided by y square. So this and this resultant will be given in this. This is Fr. So now I am having the situation where F41, it's a force by the by the first particle on the fourth particle is in the upward direction, and its value would be, it's a G 2m square by y square, and the resultant force of resulting of this two is in the negative x direction. It's a G into 2m square by y square. So in this situation F net will be equals to 0. That's it, you did it. Great job. I hope this is clear. Is it clear? Is it? So now can you do this? Can you do this kind of questions? Can it be done? Are you sure? Are you sure? Let's have a look. Be ready with your pen and paper. You are not just going to watching this, but you are going to attempting this. So please attempt this. Yes. Let's say this is mass m, 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 and the dimensions of the square is a by a. So the question is, find out. Let's call this a 1 2 3 4. It's a first, second, third, and fourth. So the question says, find out force of gravitation on mass 1. You need to find out the force of gravitation on mass 1. How will you do this? So our first approach is to don't bother about the magnitude and just focus on the magnitude. Don't bother about the directions. So let's calculate the magnitude. So this is the force applied by the second particle. It's a G into m square divided by a square. This is G into m divided by the distance. What about F4? The F4 would be equals to G m square divided by a square. Yes. So we have F2, we have F4. Now, what about the F3? What about the F3? It is something like this. This is A, even this is A. So the separation between M1 and M3 is something like this. This is 90 degree. This is A, this is A. So this should be root of 2A. So this F3 could be written as, it's a G into M square divided by 2A square. I hope this is clear. So you have done your first task. What was first task? It was to to find out the magnitude by all the forces. Now next task is to find out directions. How will I do this? So let's look at this. This is the force applied by the second particle. That means second particle will apply a force on first. So second particle will attract it, and as it attract it, it is in this direction. It's an F2. Now, what about the force applied by fourth? The fourth particle will attract this particle. So this is F4. Same is the case with the F3, that this third particle will attract the first particle. So these are the direction of the forces F2, F4 and F3. I hope this is clear. So what you must understand is this is the situation that this is F4, this is F2 and this is F3. So what I need to do is I need to always look for the that can I reduce this forces. So what I need to do is let's do F2 and F4. Let's find out the resultant of this two. I'm going to find out the resultant of F2 and F4. Now one more very interesting thing is that F2 and F4 are equal in magnitude. When this F2 and F4 are equal in magnitude, I can write the resultant very easily. It's a 2 into F into cos of theta by 2. So this is 2 into F into cos, the angle between these two, it's a 90. So cos 90 by 2, it's a cos of 45 degree, and when I write cos of 45, it's a 1 by root 2. So this is root 2 times of F, and that would be equals to gm square by a square. And the resultant of this F2 and F4 is in this direction. This is F resultant. So you can observe that this F3 and F resultant, this F3 and F resultant both are on a same line. They are the parallel vectors. So the net force is Fr plus F3. Yes, it's a root 2 gm square by a square plus gm square by 2a square. So this is equals to gm square by a square into bracket root of 2 plus 1 by 2 Newton. I hope this is clear. Is it clear? So do you understand what would be the approach for this? Are you sure? Are you sure? Can you do this? Can it be done? Can it be? Are you sure? Great. So now ready for the next question? Are you? Let's have a look. The next question. An equilateral triangle is given, and on this equilateral triangle we have masses. It's an M, M, M. Let's give them a number. This is first, second and third. So the question says that find out force of gravitation acting on. Find out force of gravitation acting on any one of the particle. One of the mass particle. So let's begin. On which you want to apply a force? Which? F2. Okay. So let me calculate the force applied on the second particle. So first thing, who will apply the forces? Let's say this is the equilateral triangle, so the dimensions is A, and A. So force up on the second particle. Two particle will apply a force. First, it's a F1, and that would be equals to G into M square divided by A square. This is the force on by the first particle, and force by the third particle, it is G into M square divided by A square. So you have find it out. The magnitude of the forces. You have find it out the magnitude of the forces by the other two particles on the second particle. Now, next task is to find out the directions. So we are finding a force on this. So when force 1 will be acting, it's a force by first particle. This particle should move in this because this is the force of direction. This is the force 1. And this is the force of direction for the third particle. This angle is 60 degree. I hope this is clear. So if this angle is 60 degree, this angle is 60 degree, what I need to do is that I need to find out F net. Fortunately, both the forces are equal in magnitude. So I can directly write it's a 2 into F into cos of theta by 2. So that would be equals to 2 into force, which is, what is it? It's a gm square by a square into cos of 30 by 60 by 2, which is cos 30 degrees. So this is 2 into gm square by a square multiplied by cos 30, which should be root 3 by 2. This 2 has gone, so this is equals to root of 3 gm square by a square. This is F net. I hope this is clear. This is the F net. This is the net force acting on the particle 2. Okay, now the question arises again is that in which direction does it act? In which direction does it act? Then my answer would be that this is F1, this is F3. They both are same in magnitude. So their resulting force will be the angle bisector. So this is the direction of FR. It is the angle bisector. It is at 30 degree with the horizontal. I hope this is clear. Now suppose someone asks me that find out acceleration of of particle 2. You need to find out the acceleration of the particle. How will you do this? How will you do this? So what I can write is that simply I have find it out all the forces acting on this. It's an F net is equals to m into a. So the F net was root 3 g m square by a square. That is equals to mass into acceleration. So this mass has gone, and the acceleration would be, it's a root of 3 g m square by a square. This is the acceleration of this particle. I hope this is clear. Is it clear? Any doubts? Any doubts? Is there anything? No? Ready for the next question? Let's have a look. The question says it is something like this. Here the mass 2m is placed. Here the mass, let's say, m is placed. Here the mass m is placed. This is, let's say, 2 meter, and this is 3 meter. Let's give them a number. It's a first, it's a second, it's a third. Question is find out force acting on on mass 2m. You need to find out the force that is acting on mass 2m. How will you do this? How will you do this? What can be done? So while calculating mass on 2m, force on mass 2m, first thing I need to look is the magnitude. So it's a force due to first particle would be equals to g into 2m into m divided by a distance between this two, which is 3, this is 9. It's a 2 into gm square divided by 9. This is f1. Distance on this due to this f1, this is equals to f3, that is equals to g into m into 2m divided by distance between this two, it's a 2 square, it's a 4. So this is equals to 2gm square divided by 4. This is equals to gm square by 2. So these two forces are acting on this particle having mass 2m. So this is about the magnitude. Now let's talk about the directions. So this mass 2m is going to be attracted in this direction by this particle, and this mass 2m is going to be attracted in this. So this is the direction of force 1, this is the direction of the force, I should say it's a force 3. While calculating the resultant force, I should write it's an Fr that should be is equals to, as they look like perpendicular to each other, so the resulting force could be given as it is the F1 square plus F3 square. While writing under root of F1 square plus F3 square, I should write this as, this is 2 by 9, so this is 4 by 81. It's a g square into m to the power 4 plus this is gm square by 4, so this is 1 by 4 g square m to the power 4. So this will be it's a g into m square under root of 4 by 81 plus 1 by 4. I hope this is clear. So that should be, it's a gm square 4 4s are, it's a 16 plus 81 divided by 81 into 4. 81 into 4, it's 84 is a 324 Newton. I hope this is clear. So this is resulting force acting on the mass 2m. I hope you got this. Are you sure? Are you? Are you sure? Great. Now let's work on the second pattern of the questions. That is something like this. This is mass 2m. This is 2m. This is 2m. It is 2m. Mass m has been placed at the center. What do you want? You want that find out force acting on mass m. The dimensions, it's a, let's say 2a comma 2a. This is the dimension of the square, and this mass m is placed at the center of the square. You need to find out a force acting on mass m, obviously by all other four particles. How will I do this? So first what I understood is, let's call this, it's a 1 2 3 4. Yes, and this is 2a, this is 2a, so this will be, let's suppose this will be the something, and this will be half of this. Yes, again this will be the distance, so let's call it x. Whatever would be the distance, this will be the same, it's an x. So now let's focus on the magnitude. So force due to first will be equals to g into 2m into m divided by x square. I hope this is clear. Now what is F2? What is the force 2? This F2 would be equals to g into 2m into m divided by x square. What is due to force due to third particle? It's again g multiplied by 2m into m divided by x square. So this F1 and F3 would be equals to. What is force due to fourth particle? This is g into 2m into m by x square. This is F4. I hope this is clear. So these are the four forces. If I look at this carefully, all these are equal in magnitude. So F1R is equals to F2 is equals to F3 is equals to F4. This all are equal in magnitude. When this all are equal in magnitude, let's focus on the directions. So if I try to get the directions, this m will be attracted by this. This is force due to first, and this is force due to third. This is force due to fourth, and this is force due to second. So if you observe this very carefully, this F1 will nullify the F3, and this F2 will nullify F4. So this is F net would be the 0. That's it. I hope this is clear. Is it clear? Is it? So you can you can observe the situation from very beginning, that look at this. What are the key points? That all this masses are equal. It's a 2m, 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 2m. Yes. Mass m is placed at the center. So this is what we can say is that certain mass has been placed. Certain mass has been placed at the center of the regular size polygon. Then if it is the uniform square, when I say uniform square, I understand that a masses has been distributed such that the resultant force can convert to a zero. Then in this situation, the particle which has been placed at the center, we can say geometrical center of that polygon, or I should say regular size polygon, the net force acting on it would be a zero for sure. Definitely 100% each time, every time. I hope this is clear. Is it clear? Is it clear? Are you sure? So let's have a practice on this. And this can be done very easily and in no time. It takes almost certain seconds to do this. Let's understood that this is 2m. Even this is 2m. This is m. This is m. And at their center, a mass m has been placed. You need to find out the force acting on this mass 2m. Let's understood that this is 2a, as it is a rectangle. Dimensions would be the different. It's a 2b. So one is 2a, another is 2b, and the length is 2a, and breadth is the 2b. So what I need to do is, first let me check that this is first, this is second, this is third, this is fourth. Whatever would be the distance between these two, let's call this as a distance that can be calculated using Pythagoras. Again, this could be calculated again according to the Pythagoras, that I understand. This distance is half of the distance, that we understand. So if I write down the forces, it's an F1. Let's say, let's call this as a fifth particle. If I write down this force 1, it's a g into 2m into m divided by, let's say, x square. That is same due to F3. Do you understand that? This is g into 2m into m divided by x square. Same way. Whatever I am going to write for the F2, it's a g into m into capital M divided by, let's say it as an x square. It is same as the F4. I hope this is clear. So this is the magnitude. Now let's talk about the directions. So fifth particle is going to be attracted by this as an F1. This is going to be attracted by this, it's an F of 3. This is going to be attracted by this, it's an F of 4. And this is going to be attracted by this, it's an F of 2. So according to this, F net on this will be the 0. That's it. I hope this is clear. Is it clear? Is it? Is it clear? Is it? The question was, find force acting on mass m. This is the requirement. Find out force acting on mass m. So this F net will be equals to 0. That's it. You did it. Great job. I hope this is clear. Is it clear? Is it any doubts? No? Can you do this? Can you? Great. Let's move to the next pattern of questions. Let's say we have a circular path, and on this circular path, two objects having mass, let's say m and m, are moving on the circular path. This is the radius of this circle. That, let's look at the question. Two masses or two identical mass are rotating on circle of radius r under the effect of mutual gravitational force. Find out their velocity. So how will I do this? They always, it would be always the situation that these two objects are there, if they are moving on the circular path, then they will arrange themselves on the diametrically opposite position. So it is always the case that they are at diametrically opposite position. Now what is the force acting between these two? It's an F. This F is equals to, it's a G into M divide by, this is R, it's a 2R whole square. This is G M square by 4R square. Yes, one more thing. As they are moving on the circular path, so centripetal force must be acting on this. So Fc is equals to mv square by r. So in this situation, the gravitational force acting between these two particles, provides required required centripetal force. The gravitational force acting between these two particles provide required centripetal force between or required centripetal force to move on the circular path. So when this gravitational force provide required centripetal force, what I can write is I can compare this to, it's a gm square divided by 4r square, that would be equals to mv square by r. So this mass and mass could be gone, this r and r could be gone, this v square should be is equals to g into m divided by 4 into r. So this v should be is equals to, this v should be equals to under root of gm divided by 4 into r. This is the velocity of both the particle, as both will be moving with the same velocity. I hope this is clear. Shall I add something? If they ask find kinetic energy of system, please mind my word. It says find kinetic energy of the system. How will you do this? So look at this. We have this relation up till, it's a gm square by 4r square is equals to mv square by r. So if I solve this, it's a rr gone. So it's a gm square by 4r. This is equals to mv square. Let's multiply this by 1 by 2. It's a 1 by 2 into 1 by 2. So this is kinetic energy of one particle. They say it of a system. They are talking about the system. So when, if I look at the system, I am having two particle. Yes. So this is, so kinetic energy of the system should be equals to 1 by 2 mv square multiplied by 2. So this is equals to gm square by 8r multiplied by 2, which will give me it's a gm square divided by 4r. This is the kinetic energy of the system. I hope you got this. Have you got this? This is the kinetic energy of the system, which will give me it's a gm square by 4r. I hope this is clear. Is it is it clear? Are you sure? Great. Let me add something to find out time period of rotation on circular path. So now I want to find out the time period of rotation on circular path. So it is the same question. It is the same question. So what I understand is the my force was gm square by 4r square. Even I can relate this. Even I can compare this with the relation. It's an m omega square r. Yes, it is the same form mv square by r. I have just replace it. I have just replace it with the v is equals to r omega. I hope this is clear. So this is mass and mass has gone. If this 2 has gone, I'm left with the gm by 4r square is equals to omega square r. So this omega square would be is equals to gm by 4r cube. If this is the case, this would be omega square. It's a 4 pi square by t square. This is equals to gm by 4r cube, and this t square should be equals to 4 pi square multiplied by 4r cube divided by gm. So this t is equals to 2 pi multiplied by 2 root of r cube by gm. So this is equals to 2 pi into 2, it's a 4 pi root of r cube by gm. That's it. This is the time period in certain seconds. I hope you got this. Do you? Do you get this? Are you sure? So can it be done? Can it be? Are you sure? Can we do this? Are you? Great. So let's work on the next question. It is similar to this. Let's have a look. The question says that four identical masses moving on the circle of radius r, such as they look like moving on a square with equal velocity v. Find velocity. So go through the data carefully and let me know what can we do, what is to be done, what is to be done, or how will you do this. First they said that four identical particles are there. They are having identical, that means their masses are equal, and they are moving on a circle having a radius of r, such as they look like moving on a square. So it is something like this, that this is the circle and the four particles would be there, let's suppose at this. Something like this. This radius is given. So this radius is given this. Now you can calculate the sides of the square very easily. Yes, shall I do it for you? This is r, this is r, so this is root of 2r. This is the side of the square. So what I need to do, I need to find the velocity. How will I do this? So let me give you the hint. This is first, this is second, this is third, this is fourth. As we understand that all are moving with velocity v on a circular path. If all are moving on a circular path, that means they require a centripetal force, and that centripetal force will be provided by the F net. So what I need to do is I need to find out the F net. When I say F net, understand that it's a force due to gravitational attraction will be equals to mv square by r. So what you are supposed to do is you need to find out the net force acting on a particle, and when you write down the net force acting on the particle and you are going to compare this with mv square by r. So what I understand is you need to just pick up any one of the particle, any of your choice, and apply a force of gravitation on this. So if it is such is the case, if such is the case, then let's pick this as a 1. I am going to apply all the forces on the first. So what you are supposed to do is that you will write down the forces due to second particle, forces due to third particle, forces due to the fourth particle. Force due to fourth particle would be in this, it's a F4. Force due to second is in this, it's an F2. Force due to third, it is in this direction, F3. Now apply the law of vector addition and find out the F net and equate this with mv square by r. This is try yourself. You are supposed to do this. I hope this is clear. So can you do this? Can it be done? Can it be done? Now do you understand this kind of questions? Are you sure? Are you sure? Can it be done? Can it be? Great. Let's move forward to the next pattern. Let's suppose masses has been placed something like this. This is m and this is the number line. This is just the origin. Then this is at 1 meter. Next mass is at 2 meter. Our next mass is at 4 meter. Next is it is at 8 meter. And so on up to infinite. The question says that find out gravitational force on the mass placed at origin. You need to find out the gravitational force on the mass that is placed at the origin. This is the origin 0, 0. So what you need to do is that just try to calculate the force due to every mass, and we will look that what could be done. So let's call this as a first, this is as a second, this is as a third, and this is so on. So if I write it's an F1, it's a G into M, it's an M square divided by 1 square, which is 1. If I write due to this, this is the next force. The next force is, let's say F2, it would be a G into M, which is an M square divided by their separation, it's a 4. Next it's an F3, which is equals to G into M, it's an M square divided by 16, and so on. Now what is the direction of this all forces? What would be the direction? So this will attract, force is acting on this particle, so mass m will attract this. This is the first direction. Again this would be the direction of second. Again this would be the direction of third. So this is the third direction force, this is the second direction force, this is the force due to first. So everyone has the same direction, and when everyone has the same direction, what I can write is the that F net should be is equals to gm square by 1 plus gm square by 4 plus gm square by 16. If I find it out, the next term, it's a gm square by 64 and onwards up to infinite. So if I solve this, it's a gm square into bracket, it's a 1 plus 1 by 4 plus 1 by 16 plus 1 by 64 and onwards. So Can you add this? Do you find any hope to get it done? Do you? If you remember, probably ninth or 10th class, this is the GP. It's a geometric progression. Yes, how do I know that this is the first term, this is the second term, this is the third term, and this is the next? For GP, a ratio of consecutive terms will be equal. If this is the case, if this is the case, then it could be considered as GP. It's a geometrical progression. So let's take a ratio of this. This is 1 by 4. This is 1. It's a 1 is to 1 by 4. Again 1 by 4, 1 by 16. Again 1 by 4. Again 1 by 16, 1 by 4. Again 1 by 4. Yes. So this is in GP. And when it is in GP, the addition of the summation for infinite numbers. For infinite. This Sn could be written as A upon 1 minus R. While, while A is the first term of the series. A is the first term of series and R is the ratio. I hope this is clear. So this F net can be considered as this is gm square into bracket 1 plus 1 by 4 plus 1 by 16 plus 1 by 64 and onwards. And while writing this I understand that this is GP, and while GP I need to do this. It's an Sn is equals to A upon 1 minus R. A is the first term, this is 1 upon 1 minus the ratio of this 1 is to 1 is to 4. It's 1 by 4. It's a 1 minus 1 by 4, sorry. So this is gm square into bracket 1 upon 1 minus 1 by 4. It's a 3 by 4. So this is equals to 4 by 3 gm square Newton. This is net force acting on the mass particle which has been placed at the origin. I hope this is clear. Is it clear? Any doubts? Is there anything? Is there anything? Is there anything? No? Are you sure? Are you sure? Great. So let's just wind it up this session over here. This was the force of gravitation and their vector form. Yes, always follow the key points that has been decided by us, that first we will focus on the magnitude, and then we will focus on the directions, and at last we will apply the law of vector addition, and things will be done easily and effectively. Please focus on this unit very carefully, because this unit will create a base of us for the unit first class 12. It's an electric charges and fields, because everything is similar when I compare this gravitational force and electrostatic force. So this will help us to understand that unit very very fast. I hope this is clear. So please do this, please do this, please practice a lot this kind of questions based on the force of gravitation. This will help us to understand them, and this will help us to calculate them very quickly. I hope this will clear all your doubts. Thank you. Have a good day. Take care.